explorers and why we need them. So I think we can all agree that space is really big. With our bare eyes on a clear cloudless night, we can see between 2,000 to 5,000 stars, and the closest of these are several light years away, while the furthest are several thousand. And before the telescope was invented, space was something that did not expand beyond the limits of our vision. It rested over our heads, and it was kind of just there, but people couldn't actually reach it, and it was something that was unattainable. But as soon as the first telescope was invented, suddenly the night sky became this mysterious expanse that contained physical things that people could actually explore. So everything was changed, and people began to look beyond what they could just see before them. So as you guys can see, telescopes have changed pretty dramatically over the course of the several thousand years they've been around, and now there are eyes and ears into space. So I'm going to talk about one specific telescope here for a second, and it's called the Kepler Space Telescope, and that's Kepler. What Kepler does is it's a space observatory that was launched by NASA back in 2009, and its goal is to find Earth-like planets orbiting other stars in our solar system. And its ultimate goal, I think, is to find proof that there could be life elsewhere. So what Kepler does is its field of vision is in those little squares, and so it's only focused on about 100,000 to 200,000 stars that are in the Milky Way between the Cygnus and Lyra constellations. So the way Kepler finds planets around these stars is pretty simple. So Kepler's a photometer, so it measures the light output from each star in that selection. And there's usually fluctuations in the light, and if there's ever a decrease in the light output over time that is periodic, that usually corresponds to something that's crossing over the face of the star and blocking out some of the light that Kepler records. And from formulas like Kepler's third law and just other models, we can actually determine that those could be planets. And most often than not, when we do have these kinds of transits and dips in light output, it's like 90% of the time they're actual planets. So, so far Kepler has been very, very successful in its search. And by February of 2011, Kepler successfully located 54 planets that could be in the habitable zones of stars within the 100,000 stars that it observes. And the habitable zone of a star is the specific distance from the planet to the star that wouldn't be too hot or too cold for water to form. So Kepler proved that there's 54 planets within this range of stars that it could find. And just 3 years later, that number increased to 961 habitable planets in other solar systems, with another 2,903 unconfirmed planet candidates. So these are some of the ones that most closely resemble Earth. Obviously, we can't take pictures of these planets because they're way, way too far away, and we don't have the digital imagery that we can't take these pictures, so these are just artistic representations. But way over there on the right, that's Earth for comparison, and then these are based on the data that we know from these planets and from the stars. That's what we think they would look like. So Kepler has confirmed 1,000 stars. We can say roughly 1,000 stars 1,000 planets out of 100,000 stars that it observes. And so that's just a fraction of the number of stars in the Milky Way. So astronomers can estimate that out of the billions and billions of stars that are in the Milky Way, there's probably around 8 or 9 billion planets that are habitable within the Milky Way galaxy. And so considering all of this, to me, it seems highly unlikely, statistically, that Earth is the only one that could support life, or that has life on it already. But whatever lies beyond us, for now, is really out of reach, because we lack the power, the technology, and the resources to actually reach out to these places and explore them. And even with all the progress that research and science has made, out of the billions and billions of planets out there, we've barely even made it past the first 8 in our solar system. And these thoughts, to me, quite frankly, are very, very humbling, first and foremost, because as we unravel the mysteries of the universe, we're faced with a lot of obstacles. The financial and technological limitations that space imposes on us, and that the limitations to what we can do and what we can understand with space are unimaginably huge. And that's why so much funding has been cut from space exploration and NASA, because all the questions, if we answer one question with regards to space, it usually just uncovers like hundreds and hundreds more questions and limiting obstacles that seem to get us nowhere and offer us no immediate answers. But these limits and these obstacles and these unanswered questions, they aren't necessarily hindering, because limits and questions fuel curiosity. And without any of these limits, or without any unanswered questions, or if we knew the answers to everything that we questioned about space and everything, we would really have no need for curiosity. And without curiosity, we would lack the drive to discover, and we'd lack the humility to explore. And in my opinion, science isn't just about finding immediate answers to the problems we have. It's about things like exploration, discovery, and innovation and creation. And these things happen only when we use our curiosity to take risks and broaden our minds. And in my opinion, space exploration teaches us to do just that. So this is what I mean by that, is that a lot of the stuff that we study in space just doesn't really make any sense. We barely know what's going on half the time. And like, for example, things like dark matter and black holes, like we know they exist because we've proven them, but we have no idea how they work. So when we try to use our laws of physics to explain them, these theories fall apart and we're left lost, and we kind of have to start again from scratch. But space exploration teaches us to not turn away and not fear this unfamiliarity. And instead it teaches us to embrace the unknown. And so this is important because they say that it's human nature to fear what we don't understand. And in a world full of diverse ideas and beliefs and people and cultures, we just have to realize that there's always more than one way to look at things, and that different ways of thinking are not only okay, but that they can be completely revolutionary. So this mindset of generally embracing the unknown that we can learn from space, if we can apply it to Earth, it will help us overcome, our own Earth-based social, financial, or economic, political, ethical problems on Earth, as well as those problems that obstruct our access to what lies beyond it. So basically that's why I believe that space exploration is really vital to the human spirit, because the sheer amount of unanswered questions that space holds is intimidating. But it's important to embrace this challenge and to embrace our own humility and to embrace our limits, because they can help us achieve great things. And one thought that I think is, beautiful is that Kepler, the telescope that I was just talking about, it's proved that almost any star out in the solar system, or out in the galaxy, could be a sun to a planet and could provide life. And to me, that kind of knowledge is invaluable.
Thanks everyone so much for coming. I'm just going to say a few quick words in conclusion of the first time we've done this event. I'm glad to see a lot of new faces and a lot of old faces of people who have come out earlier today, or maybe this is the first period that you came. I know that Nathaniel thanked everyone earlier, but I'll just reiterate those thanks to the administration, Mrs. Staves, to the teachers, Mrs. Siamaka, Mr. Koenig, Mrs. Scaly, Mrs. Fisher, and all the teachers who spread the word and brought their classes down here for the event. I want to thank the students for preparing outstanding talks, and of course, all of you for coming, and I also want to thank Nathaniel for doing an excellent job preparing, and so I want to give everyone a round of applause. So just as closing remarks, I asked earlier today why TED Talks were worthwhile, and I'm sure for every person in every TED Talk there's a different answer to this question. Because each TED Talk you may feel a different way about each TED Talk. They offer different opinions. For example, Matt Holter's TED Talk about morality. You might feel differently about morality than the person sitting next to you. You might feel differently about religion than the person sitting next to you. But Matt's TED Talk still made us ask the same questions about morality and religion. It made us ask, how do we think about atheists? How do we create a moral compass that lets us lead our lives in a positive way? And this is precisely why TED Talks are so worthwhile. They make us ask questions. They raise the questions that we don't already think about all the time. So here's a question. What do we question? What are the things that we already question in our everyday lives? We question war. We didn't used to do that. We question racism and sexism. We didn't used to do that. We question the abuse of fossil fuels and natural resources. We certainly didn't used to do that. So I think that the questions that we ask demonstrate the progress of humanity, and TED Talks make us ask more questions. And so Socrates taught his pupils through a dialogue of interrogation, and while we shouldn't view our student speakers today as teachers, we should view them as partners in discourse, partners in questioning, in raising more questions to improve the world. But let's not act too lofty. Really, what are we? We're just a bunch of high schoolers watching our friends give awesome presentations, and it's probably better just to look at it that way. So in my lonely free period 6 weeks ago, I thought, why not have a TED Talk event at Stoga? Just because it had never been done before. I know that there are a lot of students out here, a lot of people in the crowd right here with amazing ideas, great passions, and we really need a venue to spread these passions, spread these ideas, and raise more questions. So Nathaniel and I made TEDxStoga to create a platform for questioning and a platform for ideas. I really hope that this event will continue in years to come and even expand, get more speakers, more events, all over the internet. We can all be famous. Yay, that'd be great. So, thanks everyone for coming and have an awesome time.